another technique to find antiderivatives is called integration by parts. Because sadly, sometimes you cannot use substitution.
What?
And what integration by parts does is basically undo the product rule. Remember the product rule for derivatives? So I'm going to derive this with you, but I'm not going to ask you to derive it. Okay? So I just want you to see where it comes from. And maybe knowing where it comes from will help you to understand it a little bit. All right, so we're going to start with the product rule, which is the derivative of, and I'm going to use u and v as my functions instead of f and g, because u and v are what the formula is in every book. Okay? So the derivative of u times v is equal to, the product rule is first. So this is u dv dx, d second, plus second, which is v du dx. So first d second plus second d first. All right? And because I have, with respect to x here, does it matter if your variable is x or y or z or m, n, o, p? No. So I'm going to just get rid of this terminology because it could be with respect to any variable. Okay? So what's our next line going to be then? The derivative of u times v is equal to u dv plus v du. All letters on the board today. You know, calculus when all the letters on the board have no numbers with them. Okay? So what I'm going to do... Well, you know, with all my technology struggles today...
You can edit that out. Thanks for nothing, Andrew.
Laugh away. Okay, here we go. So now I'm going to subtract from both sides. Minus v du equals u dv. All I did was subtract one of them from the other side, and yes, I can edit them out. Hallelujah. All right. Now I'm going to just switch the equation. I'm going to flip the equal sign, meaning I'm going to just flip these two. Okay. So we're going to put on the left side now u dv equals the derivative of u times v minus v du, all starting with the product rule. And now I'm going to pull out my magic integral marker.
Do we get one of those?
If you want, sure. There it is. And I'm going to take the antiderivative of both sides. Is the magic integral marker working? All right, so here we go. U dv on this side equals, and now I'm going to distribute, quote unquote, the antiderivative or the integral symbol. So this will be the derivative, the integral of the derivative of uv minus the integral of v du. Because, you know, integration has that property where, if you know the... You can separate it. Very nice. Okay, so let's look at this line here where it says the integral of the derivative. What does that mean? The derivative of an integral. What are they? What process?
Oh, it is that function.
It is. It's right. It's just uv because they are inverse operations of each other. So this says take the derivative, but don't. Okay, so we're going to say this is uv minus the integral of v du, and this is the integral of u dv. So this right here, believe it or not, is the formula for integration by parts.
That's a long one. Circle star memories.
No numbers at all.
The only numbers I've written on my paper is the date.
Yep.
I wrote golden one.
Okay, so let's say it together. The integral of u dv is equal to uv minus the integral of v du. There you go. You said it together. Now, how do I remember this? As silly as it sounds, UV rays from the sun minus the integral of voodoo.
was thinking voodoo every
There
time.
you go. You're thinking voodoo. You're right. Okay.
I don't please my kids.
So let's talk a little bit about this formula. The integral of u dv equals uv minus the integral of v du. So when using this formula, in order to find the antiderivative, we need to know what u and v are, don't we? Because that's what we have to plug in. So we have to figure out what u is, and u is typically something that differentiates to 0 eventually. Can you think of a function that differentiates to 0 eventually? 5x squared, because if you take the derivative of 5x squared, you get 10x, and then you get 10, and then you get 0. So, yeah, a polynomial fits that bill. All right?
Not e to the x.
And then dv is something that integrates easily.
Wait. So the blue is only the letter u.
Is u, yeah. So I'll put u over here. And dv is something that integrates easily. And can you think of something that integrates easily?
Square root of x to the 30th minus.
No, Ted, no.
1 over.
Constants.
1 over x.
Well, what's our favorite function in the universe?
X.
E to the x.
E to the x. Because its derivative is e to the x, but its integral is also e to the x. So something that integrates easily. Now, when do we use integration by parts? We use it when we're integrating something that has two families of functions together, like a log and an exponential, or a log and a polynomial, or an inverse trig and a polynomial. Do you know? So when you are given an integrand that has two families of functions multiplied times each other, that's when you're going to use integration by parts. So the challenge is finding out what u is. So there's an acronym for the family of functions to choose as a hierarchy the order in which you should choose u. And that's Lipit. So can you think of a family of functions that starts with L? Logs, good. So if we have a log in our integrand, then we choose that as u first. What about I?
Inverse trig.
Inverse trig.
Actually.
He's right.
We don't have to say that when it's done.
What?
Polynomial.
Polynomial.
It's getting suspicious.
I don't know.
Exponential.
And guess it up somewhere.
Exponential.
And then just trig. Labeled trig function.
How did you know that? Where are you reading this from?
He's probably got my notes somewhere, right? That's the.
You probably bought them from somebody.
So trig functions. So Lipit stands for the order in which you should choose u. So logs go first, inverse trig second, polynomials third, exponentials fourth, and trig functions fifth. Okay? So let's try one.
Now we're talking.
This is example 1. Here we go. This is going to be the integral of x cosine x dx. First of all, are these two families of functions, different families multiplied together?
Yes.
Yep.
Yep. All right. So now, in order to use this formula, the integral of u dv equals uv minus the integral of v du, we have to know what u is. So we have an acronym, right, that helps us figure out what u should be. And I had a polynomial and a trig function in this.
You gotta choose x.
So we're going to let u equal x, because that's the polynomial factor. And then dv is just whatever's left in your integrand, which is cosine x dx. Alright, now, in order to use this formula, we need u, which we have, and we need v, but I don't have v. Is there a way to find v? Find the antiderivative of cosine, which is sine. Good. And now we have v, but we need a du. So how do I find du? You differentiate u and get dx. So now we're just going to follow the formula. So this integral is going to equal, what's u times v?
X
Sine x, good, minus the integral of now v du, which is going to be sine x dx. And we know the antiderivative of sine x, negative cosine x. So this is x sine x minus negative cosine x plus c. And you're done. Easy as pie. All right, let's do another one.
Read cosine c squared. You go back.
Sure, I'll go back.
Example 1 is the first number we heard today.
That's nice. Yes, sir. All right, so let's try another one. This is example 2.
And there's another one.
The integral of ln x dx. Now, I'm going to ask you, are there two families of functions we're multiplying times each other? And I would say to you, yes. We have a log, and then we have
Coefficient.
the coefficient of 1, right? So that's kind of a polynomial. I know that's deceiving.
What? You always say that about
Yes, I guess you could. But whenever you see a log, you need to think integration by parts unless you see its derivative. Okay, do we see ln x's derivative anywhere in that integral?
Wait. So you mean it feels like ln
You
x
don't
over
see
x?
1
Yes.
over x.
What did you just say? When you see log?
When you see a log all by itself, and you don't have 1 over x with it, because if you see ln x over x, that's going to be u substitution. Here, I don't have 1 over x, so I can't use u sub. All right, so we know we have to use integration by parts, which is the integral of u dv equals, everybody, uv minus the integral of v du. Good. All right. So now what is u? Remembering our acronym of lipid?
ln x.
That's right. U equals ln x, and then dv is whatever's left in your integrand, which is, well, 1 dx, yes. And now let's differentiate u, and we get
X.
1 over x dx, good. And then v is
X.
x, very nice. And now we just plug it into our formula, which is uv, which is, good, x ln x minus the integral of 1 over x times x dx. So what happens now when you have 1 over x times x? That cancels, and so we have x natural log of x minus the integral of dx, which is just x. So this is x ln x minus x plus c. It's really, most people like integration by parts because it's very formulaic. All right, another one.
Challenge us a little.
No, not yet.
This is example number 3. A number, yes, that's good.
Definitely choosing x squared.
This number 3?
Yes.
Okay. All right, so of u dv equals u d minus the integral of v du. So, Lippitt says we're going to choose
U as
x squared because that's polynomial. That's right. So we'll let u equal x squared, and then dv is what's left in our integrand, which is e to the x dx. And we need a du, which is 2x dx. Now watch it here. Although this is u, this is not u substitution, is it?
No.
So we are not solving for anything. We just leave it. Because we're going to use it as part of the formula, right?
Don't divide 2.
No, do not divide by 2. That's the biggest mistake calculus kids make. So watch that. All right, so v equals the antiderivative of e dx dx.
E to the x.
So using our formula, it'll be
Would you put an x at the end of e to the x times x?
I'm sorry?
Would you put an x at the end of e to the x times x?
No,
Oh, okay, never mind.
because the antiderivative of e dx is just,
E to the x.
yeah, but when I take out my magic integral marker and I do this, is that x times e to the x? It's just e to the x. You're not integrating this piece.
My bad.
No, that's fine. Good question. All right. X squared e to the x minus. Now, I always bring my constants out in front right away. So when I'm multiplying v times du, we're going to get 2x e to the x dx. So I'm going to just bring the negative 2 out in the integral of x e to the x dx.
X plus 4.
Well, is this another?
Oh, you have to do it
You
again.
got to do it again.
That's not nice.
Do we call it U and V again?
So, we're going to start the process all over again. Why do we have to do it again? Because we have a polynomial times an exponential.
Yeah.
So we're going to let u equal
X.
x. Good. dv is what's left, which is e to the x dx. Differentiating u, we get
Yes.
dx. And v is just e dx. All right, so rewriting this, we're going to say this is x squared e to the x minus 2 times, and I'm going to put a big bracket here because now I'm going to do this integral, u d minus the integral of v du. Okay, so we get then x e to the x minus the integral of e to the x dx. Now, why are we relieved to see that?
It's just e to the x.
That's just e to the x. We don't have to use integration by parts or use substitution or anything to integrate that one. Oops. Okay, so I'm going to distribute everything. So this is x squared e to the x minus 2x e to the x plus 2 e to the x plus c. Pesky negative. Yep, I've watched that. All right. Would you like to know a shortcut method when you have a polynomial like this times? Okay. Tabular. So I'm going to suggest to you, let's say we have x squared e to the x dx. And the factors that you're going to use for u are going to go in this part of the table. U and its derivatives, right? And then the dv's and the integrals are going to go in this column. So, what did we say u had to be here? X squared. And then what are all its derivatives until it exhausts itself to 0?
2x.
2x,
2.
2, and then
0.
0. Okay, good. And then the dv's are going to be e to the x. At dx you don't have to show because we're going to integrate it. Now what's the integral of this?
E to the x.
E to the x,
E to the x.
e to the x, and
Yes.
e to the x. Good. Now the thing you have to remember about this tabular method is this is the easy part. But now we have to remember that we are going to put plus, minus here. You start with plus and you alternate the signs down. And then we're going to multiply in a downward diagonal until you get to 0. And then 0 times anything is just 0, right? All right, so then let's read what our solution is.
X squared.
Good. X squared e to the x, minus
2x
e to the x
plus 2 e to the x.
plus the cupcake. Now is that easier?
Yes.
Much easier. All right, so let me do another example for you. I don't know what number I'm on.
4.
Yes, sir? Yeah. What?
Example 4.
This one's 4?
Yes.
Let's say we're doing the integral of x to the 5th times sine x dx. Now we had to do x squared e to the x how many times? Twice, didn't we? So x to the 5th means I'm going to have to do this 5 times. But I have a shortcut.
The tabular method.
The tabular method, right? So this works for these kind of problems. So remember, what goes on the left side are u and the du's, and then on the left side it goes the v and the v's. Okay, so what are we going to let u be in this case?
X to the 5th.
X to the 5th, because that's the polynomial piece. So what are the derivatives? 5x to the 4th, 20x to the 3rd,
60x squared.
60x squared,
120x.
120x,
120.
120, and
0.
0. Wow. Can you imagine doing this 5
No.
times the other way without the
I
tab?
mean, I
the tablet?
can.
Yeah.
And
That'd
that's
be
how we would do
terrible.
it.
All right, so what is our dv function? It's going to be sine x. The antiderivative of sine x is negative cosine. Good. Antiderivative of negative cosine. Negative sine x. Good. Antiderivative of that is cosine x. Then
Sine x.
sine x, yes?
Negative cosine x.
Negative cosine x. And then we're back here, right? And then we have to plus, minus, plus, minus, plus, minus, plus. And then we are multiplying diagonally downward. And so then let's read our answer off the table. Negative x to the 5th cosine of x. Everybody follow that? Now what's this? Is a negative times a negative. Plus 5x to the 4th sine x plus 20x cubed cosine x minus 60x squared sine x plus 120 x. Oh, it's minus, isn't it? Yeah, it's minus. Minus 120x cosine x plus 120 sine x. C, yeah, you can't forget the cupcake. So I,
That's fun.
for many years, didn't
Way
teach
more
the
fun.
tabular method, but it's grown on me after some of these years, okay?
You made those poor kids do the.
Yes, I did.
You know, you're an
You
AP
don't like the
calculus
tabular
when
method?
your answer doesn't fit. on the
Yes, you know
line.
you're in AP calculus when your answer on the smart board has to be wrapped around. Yes. All right, so another one, another type. This is example number 5. Is it number 5?
It is.
Integral of e to the x cosine x dx. Are these two families of functions multiplied together?
Yes.
All right. Lipit says
EDX.
e dx is going to be u. And then dv is what's left in your integrand, which is cosine x dx. Du is
E to the x.
e to the x dx. And v is good, negative sine x. And remember, my formula is the integral of u dv equals uv minus the integral of v du. Now, we can't do this using the tabular method because nothing goes to 0, does it? Okay, so this will equal then negative e to the x sine x, because that's uv, minus the integral of v du. But let's talk about what v du is. It's negative e to the x sine x, which makes this now positive. E to the x sine x dx. Uh-oh. Gotta do it again, don't we?
Will this keep on going and going and going?
It might. So let's see what happens.
Let's
Feels
just
like
stop
it feels
now.
like it feels like
Let's
it will.
stop
It
now.
really feels like it will.
I really see it go.
I believe
It
you.
goes on forever. Yeah, I feel a little nervous right now.
We believe you.
But there's a trick. Well, not a trick, but a sleight of hand, maybe?
Isn't that a trick?
Yeah, it might be a trick. Okay, so let's see here. U is going to be, we're not messing with, now U is e to the x again. And then dv is what's left in your integrand, which is sine x dx. And we need a du, which is e to the x dx, and a v, which is,
Cos.
it is negative cosine x. All right. So what do we have so far? We have negative e to the x sine x plus, well, it's really minus, right? Minus e to the x cosine x minus, which becomes a,
No, it doesn't keep going. Oh wait, yes it does.
Because it's minus and negative.
that's not helpful.
Just put dot dot dot.
Oh, you know what? We made a mistake.
Oh no.
No, we didn't.
Yeah, we did, because what's the antiderivative of cosine?
Sine.
It's positive sine.
Listen to me, so your first mistake.
Okay, so whoops. So this right here is a minus here, okay?
Sand, you're listening.
Got it? That's a minus?
What
And
about
then
the
equate it to
first
the
term?
first line.
The first term would also be
Yeah.
positive.
Yeah, first term's also positive. You're correct.
Okay.
Ugh.
Now we're back on track.
All right, here we go. So this is e to the x sine x minus now this new integral, uv minus the integral of dvu, right? Which is going to be, did we do this right? Yes. Negative e to the x cosine x minus the integral of e to the x cosine x, but that's negative, so what does that become? Yes, this one is legitimately positive, but I have to distribute that pesky negative in front, don't I?
Yes.
I have to hurry here. So this is equals e to the x sine x plus e to the x cosine x minus the integral of e to the x cosine x dx. But you look at that and you go, but Mrs. Muller, oh my gosh, we're going in circles here, aren't we? But what is this?
Your original.
This is my original. This is
So
what
we
I
can
started
plug in.
with. Okay, so what we're going to do is we're going to go back up to the top, and we're going to lasso this. There it is. And we're going to bring it down here and say the integral of e to the x cosine x dx. And this is right here, the sleight of hand. But I don't want you to think of it that way. What if,
Sleight of hand?
right now, this
Okay.
moment, what if I decided that I would add this integral e to the x cosine x to both sides?
You would get 2.
Yep.
Oh my goodness.
Now that's legitimate, right? So then we get 2 of them on this side,
Wait, I thought that became. Oh, and then you
and
divide
then,
by 2.
and then you just divide by 2.
I thought the integral became positive when you distributed the remainder.
Well, because negative is positive, and this one is now negative, because this.
Oh, it was already
Yeah.
positive and then became negative.
And then now to get that integral all by itself, we have to divide by 2. So this is the integral of e to the x cosine x dx equals e to the x sine x plus e to the x cosine x all over 2 plus c. All right? So we didn't have to do it. We only had to do it how many times?
Twice.
Twice. For functions like this that you're multiplying together, you only have to integrate it twice, and we call this one solving for the unknown integral. And the technique for that is just to add it to the other side, okay? So that's kind of what I have for you today.